Well, welcome everybody. I'd like to start the meeting tonight by acknowledging the traditional custodians of the land in our electorate of Reed and acknowledge that that land has never been ceded. I'd also like to pay our respects to elders past and present and support their struggle for recognition. I'll now introduce our guest speaker, Professor David Karoly. He is honorary professor at the University of Melbourne, having retired from the CSIRO early in 2022. He's an internationally recognised expert on climate science and climate variability. From 2007 to 2018, he was Professor of Atmospheric Science at the University of Melbourne. Prior to that, he held the Williams Chair in the School of Meteorology at the University of Oklahoma. He's been involved in the assessment reports of the IPCC in 2001, 2007, 2014 and 2021 in several different roles. Tonight, he'll be looking at how near-term climate predictions have stacked up against observed climate change in Australian cities. So, over to you, David.
Okay, and what I did, as you will have noticed, is I've stopped sharing because I ended up with a problem with the record button. I will go back to sharing again now, and hopefully this will reappear in just a second. How does that look to everyone? Looks like I'm sharing the screen and it looks as though it's coming through okay.
It does.
Okay, so look, I have been involved in lots of different, if you like, research on climate variability and climate change. And about 15 years ago, was asked by CSIRO to review their climate change projections, or their set of climate change projections that was being prepared in the late 2000s decade. And it was based on the IPCC fourth assessment report and climate model simulations that were undertaken in that. And I asked them, you know, why weren't they doing some evaluation of the climate projections? They had done some, but not very much. I asked the same question as they started to prepare their next generation of climate change projections. And I'm going to talk today about some evaluation work that I've undertaken to evaluate the performance of some of the most recent national climate change projections that were released by the Bureau of Meteorology and CSIRO in 2015, based on the fifth assessment report of the Intergovernmental Panel on Climate Change and climate model simulations that were undertaken and fed into that assessment report. And what was done in that assessment was really to look at large scale, whole of Australia and some regional scale evaluation. But in practice, national projections, while they're really important in looking at climate change on a large scale or a continental scale, what is most important for people is getting evaluation of the climate projections at local scales. And the only local scale information that was provided in that report released in 2015 was at 5 kilometre spatial resolution, which was good. But then it was a series of climate projections for Australian cities, all the capital cities and some other major cities in Australia. And I thought, well, if there were assessments available, people would be able to assess how well those projections were. And I'm going to talk about that now, because this project started with an undergraduate student and then a master's student doing some of this assessment of projections of near-term climate change in Australian cities. It ended up being quite difficult to do, basically because we wanted to get the highest quality observational data. It's going to take me sort of, as I said, now 25 minutes to get through some of this. And what I'm going to do is race through. But an example of this climate projection is this panel on the left-hand side, which has a triangle in it. And I can't quite point at it at the moment because, unfortunately, I've got people's images hiding my screen and I haven't worked out how to get rid of those images. I should have done it earlier. But anyhow, I've got a pointer and it's not, well, yeah, look, I'm not going to try and get rid of it. What you can see on that triangle is climate change projections from out to 2030 that are set at the sort of mid-range period, 1995, that was available for the most recent 20-year period in the observations, and they were using a 20-year baseline, and then the projections of rainfall for the southwest of Western Australia. The thick black line shows the observed 20-year average rainfall for that region, southwest of Western Australia. The blue line is the year-to-year variations of rainfall. What you see with the 20-year projections is a range out to 2030. And what you find is that the rainfall observations right up to 2020 were tracking not in the mid-range of the projections, but they're actually tracking at the worst case of the climate model projections for the period from 1995 to 2000. And that would suggest either that the models are underestimating the rate of rainfall change, or that the observations are not representative, or maybe the climate models are not representative of what was actually happening in the real climate, or something else. And we'll talk about a whole range of reasons. Maybe it's just natural climate variability that wasn't included in the climate model simulations. So that's enough background. What I'm going to do now is briefly show you a timeline. The very first Australian climate projections from CSIRO and then from CSIRO and the Bureau of Meteorology were released not with graphics, just with text projections way back in 1990, timed to essentially align with the first assessment report of the Intergovernmental Panel on Climate Change. CSIRO had been doing research work on climate change, and there is a wonderful book that came out from a CSIRO organised conference in 1987 called Greenhouse: Planning for Climate Change, that was released in 1988. Now, that conference and then action on climate change in Australia became a political hot potato. CSIRO continued to do every 5 years or so, aligned with the assessment reports from the Intergovernmental Panel on Climate Change. The second assessment report came out in 1996, the third one in 2001, fourth one in 2007, fifth one in 2013, and that was the basis for this most recent national climate projections that were released in 2015. Supposedly, if it wasn't for COVID, the next set of IPCC assessments would have been released in essentially 2020 or even earlier, but there were significant delays of more than a year or two in the completion of the sixth assessment report of the IPCC. The first volume should have come out in 2020, and then it was supposed to be completed in 2021, and that would have fitted in with slightly longer than 2013 release, but look, it was voluminous. It's now only just been completed in 2023. The synthesis report came out about a month ago. So that's the timeline. There has been an extremely good evaluation of these recent climate projections undertaken in Australia. If you want that, it's in the references at the end, and I will be sharing my slides, and you can get them from the references. If you want to have a look at this evaluation of how good or poorly for the whole of Australia and in different regions of Australia, the climate projections did from 2001, 2007, and 2015. But fortunately, in this most recent IPCC assessment, there are assessments of global temperature projections from climate model simulations, individual climate model simulations, as well as the IPCC assessment reports in the dotted lines. And the observations from 1970 right up until 2019 are shown with this thicker black line. And what you can see is that the very earliest climate model projections of what might be expected for increases in greenhouse gases are shown here from 1970 onwards, essentially this Wally-Broker peer-reviewed journal publication. You can also look at the first assessment report of the IPCC that was prepared in 1990. And essentially what you see is that there's a very good agreement, not of the year-to-year temperature variations, which are associated with natural climate variability, but for the long-term changes in global mean temperature. They agree very well, even with climate models that shouldn't have been doing as well with their climate projections. And it turns out that these early climate model projections, like the ones by Jim Hansen or the ones by Wally-Broker, as well as the first assessment report from the IPCC, the global climate models took into account the increases in greenhouse gases, but they did not take into account the compensating cooling influence of anthropogenic emissions of sulfate aerosols, which have been offsetting a significant part of the warming influence due to increasing greenhouse gases. Turns out that these model simulations underestimated the warming due to increasing greenhouse gases, and it's only in the third assessment report that the model simulations and models have effectively taken into account both the increases in greenhouse gases and the offsetting influences of aerosols. Now let me move on, because I want to talk a little bit more about the Australian projections. But to understand the Australian projections and that evolution of climate models, it's only if I essentially spend a little bit of time talking about the evolution of climate models and the spatial scale at which climate models are essentially representing physical processes in the atmospheric system. And this is a bit of background. I'm going to race through it. As I said, in the mid-1970s, yes, there were climate models, but they were extremely simplified. Effectively, they had spatial resolutions only of the order of 500 to 1,000 kilometers. They did not represent the whole of the globe. Some of the very early models, they represented sectors of the globe and assumed that they had a fraction of the land. Later on, they had land surface better represented. And it's only really when the first assessment report of the IPCC came out that it started to have assessments of climate models that had representations of the oceans and clouds, but did not have representation of any of the sulfate aerosols, the emissions from industrial activity from coal-fired power stations that were leading to particulates or aerosols in the atmosphere that were reflecting sunlight. They also had representations of volcanoes. Much later on, there's been improvements in the representations of ocean circulations, much better representation of, as I said, sulfate aerosols, much better representation of interactive vegetation, interaction of the carbon dioxide in the atmosphere with vegetation, with uptake into the oceans. As the climate models became more complex, there was coupling between all of these different cycles, between vegetation, between the ocean. That made the models more complicated. They did end up with better representation of the year-to-year variability. But there was also substantial improvements in the spatial scale of the representation. The most recent global climate models now have 50-kilometer spatial resolution, but the limitations in the model simulations is usually associated with the computer power that is available for undertaking the simulations. And it's also important to understand that there's not just one climate model that's run. There are now more than 50 different independently run global climate models that are used and analysed to prepare climate model projections globally and regionally. And what I'm going to do is talk about why there may be differences between the results of different climate models, partly because they've got different horizontal resolutions, partly because they've got different numerical schemes for solving the equations that represent the motion of the atmosphere and the ocean, but they also represent processes inadequately, like clouds or rainfall or radiation transfer. They have to have representation of those important physical processes, and they're usually not represented in the same way in different independently developed climate models. They've got independently developed representation of important physical processes and unresolved processes like thunderstorms that are occurring at smaller spatial scales. So what I'm going to show you now, if I get to the right set of results, is a set of individual coupled ocean atmosphere climate model simulations that took part in the 4th assessment report of the IPCC way back in 2007. These models have been adjusted so that 0 is the value in 1990. Now, it's important to remember that each of these models represents the ocean and the atmosphere and the land surface and the couplings between all of those processes. They were actually typically started in the year 2000, run out independently. They've been adjusted so the values are reset at 0 in 1990. And then they run out into the future with the observed increases in greenhouse gases and the observed increases in volcanic aerosols. But they can't run out very far with the observed changes. They've then got projected changes out beyond 2005. And all of those climate models would have stopped in their observed data sets in 2005. But now what we can see is the climate is a chaotic system in each of these in each of the climate models. They represent El Nino events, and the El Nino events that lead to large increases in global temperature associated with El Nino events. And La Nina events are like what we've seen in the most recent 2 years or so, lead to cooler temperatures globally. And you'll notice that the observed temperatures, and there are 3 different observational data sets in the colored lines here, show an El Nino event that took place in 1998-99. They also show an El Nino event that took place in 1995 and another one in 1998-99. There was a massive volcanic eruption in 1991, Mount Pinatubo, that led to cooling of the climate system. And that's really the only time that the climate model simulations agree. And in fact, all through the remaining period out to 2009, the individual climate models, because they're chaotic, don't simulate the actual occurrence of an El Nino event at the time that it occurred in the real world climate system. So we've got to understand that what we're looking at in climate model projections is not the year-to-year variability that happens in the real world at the time that it happened in the real world, but the range of year-to-year variations and only the forced responses, like the forced response to increases in greenhouse gases leading to a long-term warming trend, and the forced response to volcanic eruptions, which lead to aerosols in the atmosphere. But it's also important to understand that there is uncertainty in that future climate projection. For instance, the projections out to 2000, or the change from 1990 to 2009 over that 20-year period, there is natural climate variability on multi-decadal time periods. There's whether you have El Nino events or La Nina events will affect the trend that was apparent. And you'll often hear people say, well, there's been no warming over the last 10 years or so because they start in a El Nino event and end the period of consideration at a La Nina event. And that's exactly what people, so-called experts in the media, have been commentating, that we had an extreme high temperature. For instance, back in 2009 was an El Nino event, but now in 2022, we've had a La Nina event for 2 years in a row. So temperatures haven't grown as rapidly from 2009 to 2020. We also know when we look at these data sets that there's different responses in the different climate models, different trends from 1990 in the different climate models, partly due to natural variability, partly due to the differences in responses. And finally, we don't quite know what's going to happen beyond the observed emissions. What's going to happen to future emissions? That's going to depend upon what happens with political decisions and economic decisions about fossil fuel use and removing fossil fuels from the economic system. So there are scenarios that have been developed, high emission scenarios and rapid reductions in greenhouse gas emissions in the period between 2005 and the end of the current century and even beyond. So I'm going to talk about those in terms of climate projections. So let's look now, not very far into the future, but the Australian climate projections across a set of global climate models that were used in the IPCC 6th assessment report, and then were reported in the State of the Climate Report for 2022, released by the Bureau of Meteorology and CSIRO. This blue band here is the range of 20-year average temperatures from the climate model simulations that were started way back in 1850, run just with observed changes in greenhouse gases in this simulated past climate up until 2019, and then future climate based on projections and ranges of projections from the same climate models. There were more than 50 different climate models that were used in these data sets. And what we see is that the 20-year average observed changes in temperature in Australia from 1910 right up to the present show relatively little warming up to about 1950, and then a rapid increase in temperatures across Australia. What we can also see is that for this 20-year average, it finishes before 2019, finishes 10 years before that, because the data right up until 2019 and 2020, here's 2019, the hottest year in Australia. This is 2020, must be 2020 here and 2021 here. It's the State of the Climate Report right up to 2022, and so it was only showing the observed temperatures right up until 2021. So what we find is that many of the years lie outside the range of the 20-year average. And if we look at the 20-year average out into the future, what we see is that the 1940s temperature shown in this range here, even the mid-range in the 1940s, is hotter than the 2019 temperatures. If we go right out to 2040 here, that temperature, the mid-range in the 2040s, is actually slightly hotter than what we experienced in 2019. And what it means is that the 2019 temperatures experienced in those black summer temperatures is going to be the mid-range temperatures for the 2040. We know that those temperatures are locked in because we will have only just reached global temperatures, global average temperatures of 1.5 degrees, and we'll be below what we would expect for global average temperatures of 2 degrees. And in fact, we're likely to get to 2 degrees or but just below unless we rapidly reduce our greenhouse gas emissions. So this is the Australian temperatures. You can see from this graphic that the model simulations are doing reasonably well. So what emission scenario should we be looking at if we want to look at climate projections for the 2040s? Well, actually, for the 2040s, there's a very high overlap in both global temperature and Australian temperature between the different climate model simulations. Doesn't matter what we do in terms of emission reductions, the warming in 2040 is pretty well locked in. That isn't a reason for not doing anything to reduce emissions. It means that the time scale for the climate system to respond and the time scale for essentially limiting global warming to 1.5 degrees is needed, not just now, but these emission scenarios are lower than the observed emissions. So this is the only scenario, SSP 1.9, that it gives a good chance, greater than 50% chance of limiting warming to 2 degrees, below 2 degrees. And the other SSPs all give greater than 50% chance of warming above 2 degrees in 2100. It's important to note that in these emission scenarios, many of them give substantially higher global warming. But I'm going to focus on the short term. I'm going to focus on the short term because that was the best thing in terms of evaluating the climate projections and the climate observations at cities. So what did I do? Well, look, I thought that if there was a set of climate projections in 2015 and the shortest term projections that were available in those climate projections released by the Bureau of Meteorology and CSIRO, the shortest term was 2030, because we were already at 2015, and that was only 15 years into the future. But those 2030 projections were based on changes relative to what was called a baseline or a 30-year average from 1980 to 2010 for extreme temperatures and 1985 to 1995 for average temperatures. But I wanted to look at extreme temperatures, and I wanted to look at this at cities, at individual locations. And what I did was look at annual maximum temperatures averaged over 10-year periods, wintertime rainfall changes relative to the baseline for the most recent 10-year period, as well as days over 35 and 40 degrees Celsius and frost days below 2 degrees Celsius from the high quality observational data available in the Bureau of Meteorology. But what I wanted to do was to use independent data from any of the baseline, essentially something that happened in the future relative to when these data sets were, when these projections were released. They were released in 2015. I used the 2011 to 2020 period because none of that data was used in preparing the projections. It was independent data. So what I'm going to show you is essentially not 2030 data, because we haven't quite got there yet. The 2030 projections are for 20-year periods, from 2021 out to 2039 for the rainfall and temperature changes, and for 30-year periods from 2015, let me get it right, 2015 right out to 2045, 15 years before 2030 and 15 years after 2030. So lots of numbers. I'm now going to show you some of the results. And I should point out that this map shows you the cities that I've analysed for. Sydney, Melbourne, Brisbane, Cairns, Darwin, Alice Springs, Adelaide, Hobart, and Perth. And I'm not going to show you all the results because you'd get bored and I'd get tired. What I'm going to show you are some of the key results for different cities and essentially to get to the conclusions. And I'm going to start with Canberra. For lots of reasons, the politicians are particularly interested in Canberra. But Canberra is also a really interesting location in terms of the results. And the reason I've chosen Canberra is partly because in the period 2011 to 2020, there were some quite dramatic changes in temperatures and rainfall in Canberra that demonstrate both the good parts and the bad parts about the projections relative to the baseline period. So I'm going to be showing you a bunch of these sorts of tables. And as I said before, I'll be looking at the annual mean maximum temperature for a 10-year period in the observations or 20 or 30-year periods in the baseline. I'll be looking at mean temperatures, mean maximum temperature, wintertime rainfall, days over 35, days over 40, and frost days. And let's start with annual mean maximum temperature. The average mean maximum temperature in Canberra throughout the year, I mean, it gets pretty chilly in Canberra in midwinter, is 20 degrees Celsius. And the projected warming was plus 0.8 degrees Celsius in the 2030 period, which is essentially, because of this mid-range, it's essentially that 2015 to 2045 period. And you can look at the range in here. Unfortunately, that range is hidden because I can't get rid of the pictures. But what you'll see is that already in 2011 to 2020, we're way above not only the mid-range estimate for 2030, we're close to the worst case in the rate of warming for the 2030s already in 2011 to 2020. Now, this wasn't the worst case of all the cities. I picked Canberra to talk about here because it illustrates a number of the issues with the climate model projections. But the data set at Canberra is quite reliable in terms of, I mean, it hasn't been relocated. It's not one of these ones for which there's been major station changes. It's been at Canberra Airport since essentially the 1950s and 1960s. What about winter rainfall? Well, remember I showed you the winter rainfall decline in the southwest of Western Australia. There's also been a substantial winter, oh, I should have pointed out, back into the temperature up here, the stars indicate the statistical significance of the observed change. And what we see is that the two stars means that there was essentially no real chance. The plus minus is the standard deviation of decadal temperatures at that observational site, Canberra Airport. There weren't a lot of independent decades since 1950 that we could use, but there's a reasonable estimate of the decadal variability. And that result is highly significant at the greater than 99% level. Less than a 1% chance that it could be due to natural variability alone. Turns out that for rainfall, and the reason for talking about the uncertainty is that rainfall variations are very large on decadal timescales, and there has been a substantial 7% decline in rainfall in winter in Canberra. It is not statistically significant because there is large natural variability. But actually that observed change is twice as big as the mid-range projected change for a rainfall decline in Canberra. Yes, there is a projected rainfall decline, as well as the possibility that there could be slight increases. The reason I'm taking time over this is primarily because I wanted to race through the later ones and summarize them a bit faster. Let's look at days over 35 Celsius. Well, there were about 7 days over 35 Celsius. It's a pretty hot day, but it's not unbearable in Canberra because it's usually associated with dry conditions. That was for the 1981 to 2010 period. In just the most recent 2011 to 2020 period, they were already up till 11.3 days. And that's essentially about the mid-range for the 2030 period. But remember, this is 2011 to 2020. We've still got another at least a decade to go. And it's within the range of projections for 2030, but it's tracking from 7.1 to 11.3, going from 1995 to 2015 is 20 years in the future, a 20-year change. You'd expect changes essentially over the next 10 years to be about half that. That would mean you'd be up at 13. That's already tracking it well above the mid-range. If we follow that, and then decadal variability doesn't dominate. What about days over 40? Turns out in the 1985 to 2005 period, there'd only been 1 day in that, 2 days in that 20-year period, 1 day per decade of days over 40 Celsius. And that was happening in the 2000 to 2010 period. If we look at that 1981 to 2010, we now find that there's actually a couple more days that happened between 2006 and 2010 above 40. What about if we look at the most recent decade? Well, now we're at 16 days in a 10-year period above 40 Celsius. And most of those happened in 2017, 2018, 2019, and January of 2020. What was the climate projection? It was best estimate of only 6 days per decade and 1.6 days per year, 16 days per decade, was way higher than the uncertainty, the full range of uncertainty. So we're tracking in terms of hot extremes in Canberra at way above the worst case for the 2030s. In other words, it's been getting hot for politicians in Canberra, at least in terms of the weather. I'm not sure that that's the case in Parliament House, which is well air-conditioned.
David, we're just over half an hour in, so we've got some time for questions too.
No, I'll go for a few more because I want to get to the slides and the conclusions. It'll take me another 5 minutes because I've done all of this. We should also look at frost days. The climate model projections say that, as you'd expect with a warming climate, that frost days should decrease. And that's exactly what the climate model projections show. What have we seen in terms of frost days in Canberra? Actually, we've seen an increase in frost days because most of the frost days are in winter. The rainfall has declined in winter. That means more clear skies at night, which means a likely increase in frost days. And that's exactly what we've seen. Now, if the rainfall continues to remain low in Canberra, then we're likely to get a lower decline in the model projections because the models haven't been representing this rainfall decline as well as you can see. Let me go to Sydney. Another case, another city. I won't go through all the other cities. I will talk through this one. The annual mean maximum temperature is hotter in Sydney, as you all know, than it is in Canberra. There has been a significant increase in temperatures in the most recent decade, and that is within the range of the projections, but it is not tracking as high as the projections in Canberra. But it is, if you like, tracking already at within the range of the climate projections for the 2030s, a little bit lower. It's mainly the cities in the southern states that have been tracking worse than the the temperatures, but it's also the case in Alice Springs and in Darwin that the temperatures are tracking worse than the case. There is no wintertime rainfall decline in Sydney. In fact, Sydney rainfall in the 2011 to 2020 period, both in winter and in the annual average, has increased slightly, which is within the range of the climate model projections. But the climate model projections were suggesting both a range from reductions in rainfall to increases in rainfall. There's high uncertainty in rainfall change in Sydney for the decadal average. There's more confidence for extreme rainfall, like extreme 1 hour and 1 day rainfall. We've certainly seen those increases in extreme rainfall in 2022 and the early part of 2023 in Sydney and elsewhere, and a new record rainfall is likely to be set, or was set in 2022 and is likely to be set in 2023. Let's look at the extremes. Well, Sydney has also had increases in days over 35 Celsius and days over 40 Celsius. They were quite rare, certainly days over 40 Celsius, because the Sydney observation point is right, well, close to Sydney Cove. It's at the observatory point, which was the original observing location. And that has stayed there. There's more than 120 years of observational record. What we see is that the projected change, 4.3 days over 35 and half a day, 1 day every 2 years above 40 in Sydney, are way below what we experienced in the 2011 to 2020 period. In other words, the climate model projections are underestimating the rate of change, the rate of warming, the rate of growth in days over 35, and the changes in rate of days above 40 Celsius. So I'm going to skip Melbourne. You're not interested in Melbourne. I'm going to get to the conclusions. For most cities in southern Australia, increases in temperature and decline in rainfall are already consistent with the projections for the 2030s, and some of them are at the worst case. Projected declines in frost days have actually not occurred as projected, but have tended to increase when observed rather than decline as projected, primarily because of the winter rainfall declines. For many of the other cities, including Sydney and Darwin and Alice Springs, the changes in temperature extremes are tracking the projections for the 2030s and therefore are happening faster than the climate models would project. But the rainfall changes are highly variable between the different cities, and you can't make consistent conclusions about how good or poorly the models do. I would argue that any use of future regional climate models needs to first of all be assessed against recent observed decadal climate changes at local scales. If the models are projections, say for the near term, don't agree with what's been observed, either there's a problem with the models, or they're not representing natural variability very well, or, as I would argue in this case, climate is changing faster than the climate models project. Often it's in the same sense, but it's happening faster. And that's probably to do with the problems with climate models not resolving the appropriate processes at the right place or scales. But I would argue that if you're wanting to use climate models to plan your future, whether it's your holiday house by the beach or where you build a new house close to a flood zone, or in a what I would call a tree change environment, you might want to plan for the worst case based on climate projections. The worst case in terms of bushfires, the worst case in terms of sea level rise, and the worst case in terms of flooding from rivers. And unfortunately, many councils and many plans have been made assuming the mid-range estimate is the best thing to use, not to stress test using the worst case. I'm going to finish up there, and I'm happy to take questions, Ken. And what I'm going to do is stop sharing my screen if I can. I think you're muted still, Ken.
I was. Thank you. We've got a bunch of pre-submitted questions, but I'll ask the questions. We've got one up here that somebody's just put in. It said, would you agree that the days per year over 40 degrees Celsius in Canberra is 16 times greater from the 2010 decade versus the previous decades? And there's i.e. 1.6 divided by 0.1 equals 16. This is staggering.
It is, and it was for the people who lived there. In the previous decade, there were actually 3 days. So it's only a factor of 5 increase rather than a factor of 16, because previously the 0.1 and the 0.3 were essentially all for the period from 2001 to 2010. But that's just because I know what was there and it wasn't obvious from the tables. But yes, a factor of 5 increase in the days above 40 Celsius in Canberra is dramatic and is, I mean, it's unlikely to continue, but there was essentially a threshold issue, and the same threshold issue happens in a number of other areas. That heat stress is affecting many parts of Australia already, particularly inland areas where the temperature changes are more rapid than in the coastal areas. And Alice Springs is seeing similarly dramatic increases, not in temperatures above 40 Celsius, but in both temperatures above 40 Celsius and temperatures above 45 Celsius. And 45 Celsius will kill people outdoors, as it does in Western Sydney.
Okay, I've got a question here. Do you think that the future temperature reality will reflect the worst projections of the IPCC's models? In some geographical locations, yes. I believe that the IPCC climate model projections, both regionally in Australia and in other locations, will be higher than the mid-range of the climate model projections. And there are some assessments within the IPCC report, which ended up being essentially conservative, that you need to look across the full range of future climate projections at a continental scale and at a regional scale. And that's what I would be arguing. And it turned out that some of the high warming climate models were essentially disregarded in the IPCC assessment because they were considered to be unrealistic. If I was looking at them in Australia, I would be arguing that those model projections are the ones that are more realistic than the mid-range ones in terms of the climate projections. Okay, I've got a question here. How do temperature increases in Australian cities compared with those in other countries?
Okay, that's a really good question. And that depends geographically on where you're looking. If we look at inland areas in Australia and inland areas in some other geographical locations in the same sorts of, if you like, climatic zones, Australia has been experiencing similar sorts of temperature changes in southern Australia in its Mediterranean climates to other geographical locations with Mediterranean climates, which means the Western United States and California, means the Middle East, and Spain, Portugal, Greece, and Italy. Unfortunately, they've also been experiencing increases in bushfires or wildfires, as they've, described them. But those regions and southern Australia are experiencing those sorts of extremes. Now, Sydney is slightly more tropical, as we know, and it's experiencing similar sorts of changes to some slightly more, how would I say, subtropical, tropical environments in different locations. There is nothing specific in Australia about it being peculiar relative to larger scale temperature changes. However, because Australia is moderated by oceans around it, it has large natural variability associated with El Nino and La Nina events, more so than many other geographical locations. And its temperatures on the sort of multi-decadal timescales are a bit moderated. So the trends relative to the year-to-year variability have been standing out. And one of the areas that I've looked at is the sort of extreme events. And much of the work on attribution of extreme events has shown clearer signatures of increases in temperature extremes on the multi-decadal timescale in Australia, particularly attribution of, for instance, the extreme temperatures in the 2018-2019 Black Summer period and attribution of the extreme fire weather conditions in that Black Summer period. It was much easier to do in Australia than it was possible to do in Spain or in California, which have also experienced fires.
Okay, look, I have a question myself that I've not been able to find clarification on. You often read that Australia's had a 1.4 degree increase in temperature. And I'm wondering if that means that we have had more temperature increase than other countries, or whether that's 1.4 degrees over land, looking at the average of global temperatures, which includes sea.
Yeah, and that's a really important point. Most people are not fish. We tend to live on land or on the coast. Coastal areas have moderated temperature changes from day to day, from year to year, from winter to summer, and due to climate change. The oceans warming relative to, for instance, a 2-degree warming projection, the oceans are likely to warm by about 40% less, and the land is likely to warm by about 40 to 50% more. So 2 degrees warming globally averaged translates to 3 degrees warming on land. And in that projection for the 1.5 and 2 degree warming level over Australia, in that time plot that I showed that ran out to 2040, it had a line for the global warming for 2 degrees globally averaged, and it was set at, or appeared at, 2.8 degrees over Australia, 40% higher than the global average warming. So yes, Australia's had 1.4 degrees of warming relative to 1910.
Mm.
But if you actually go back earlier relative to the 1850 to 1900 period, Australia's had 1.5 or 1.6 degrees of warming relative to the global average warming of 1.1 degrees.
Wow. Here's a question.
Yeah, I was just going to say, we need to bear in mind that politicians and all countries are talking about global average warming. They should be talking about land average warming.
Yes.
Because most people are not fish.
Yes. Here's a question from Corinne. Will the developments at Barangaroo near Observatory Hill affect data collected over time due to the large amount of concrete, wind movements, and heat island influences nearby?
So the answer is there will be some influence, an urban influence, and there is already some urban influence on temperature increases at Observatory Point when the wind comes from the west, which comes from the city area. And we know in Sydney that the temperatures in the western suburbs have exceeded 45 Celsius. And when the wind, the day, and I should remember this, but I don't, the day that set the record temperature in Sydney was a day of very strong winds from the west coming down from the Blue Mountains, much hotter in the western suburbs than it was at Observatory Point. And Observatory Point was much cooler much hotter than if you went out into Sydney Harbour and out, because the sea breeze front had actually not hit Observatory Point and was located about 2 kilometres out over the ocean. Much the same situation happened in Melbourne as well. So look, there are major temperature differences associated with circulation, but there's also major heat island effects due to concrete and surrounding. And so Sydney is partly hotter now due to climate change, partly hotter now due to the urban influence on the temperatures.
Okay, I've got 2 questions here, and I'll get to George's question in a minute. They're related. So the first one is, how hopeful are you that we can prevent catastrophic climate change? And related to that, how can we give a more positive message about climate change so that we motivate people rather than terrify them into inaction?
So I would argue that the Black Summer fires were catastrophic and the 2022-23 floods were catastrophic, and they were partly influenced by climate change, both of them. So I would argue we've already got catastrophic climate change. Not that it's something that we're trying to prevent in the future. What we're trying to do is reduce the catastrophic impacts that are being made worse by human-caused climate change. And we know how to fix it. We can fix it now, and it only requires Australia and the rest of the world to rapidly reduce their greenhouse gas emissions so that we can limit global warming to only 1.5 degrees. But that's not 1.5 degrees being the peak in the warming. Warming will exceed 1.5 degrees by 2040 or 2050, get somewhere closer to 2 degrees globally. And then it will fall if all countries have made their commitments to get to net zero by 2050 and to continue to suck carbon dioxide out of the atmosphere so that greenhouse gas emissions fall. And we can do that using existing technologies, by planting more trees, by using solar power, using wind power, transitioning to a zero carbon economy. But if we want to limit global warming to 1.5 degrees, and Australia is to do its fair share, it has to leave the coal in the ground, the fossil gas in the ground. It has to get to net zero emissions, not in 2050, but by 2035, so that the world emissions get to zero by 2050.
Yeah.
Because the UN Framework Convention on Climate Change says that developed countries should take the lead in combating climate change. Australia still has, as a developed country, the highest per capita emissions of any developed country in the world, substantially higher than the United States, substantially higher than Canada, substantially higher than any European country. Australia needs to recognise that the only fair measure in terms of greenhouse gas emissions is per capita emissions.
Yeah. Probably only have time for maybe one more. And George seems to have withdrawn his question. But I've got a question here just from me. It goes on to one of my favourite bugbears. I can't help but watching what the so-called climate skeptics have to say. And I was watching an interview from 2 years ago with John Christie, the famous American climate skeptic. I was very gratified to see that he's no longer challenging the temperature record or the role of CO2 in causing it. But he made some downright crazy assertions. And he said, quote, "We're just putting back carbon dioxide that was there before," meaning into the atmosphere. "It is invigorating the biosphere. It also represents people living longer and better lives," unquote. And then he went on to say that there have been no increase in droughts, floods, storms, or anything that he's been able to observe over the long term. There won't be any sea level rise in the future. I mean, how do you respond to these sort of statements?
So some of those statements are correct.
Mm-hmm.
But it's important to understand that for about 99.99% of Earth's history of 4 billion years, carbon dioxide has been higher than at present.
Mm.
So we are in a relatively cool period. But what's not relevant to John Christie or most humans is that human society has only been around for of the order of a few thousand years, if you're really generous, 5 to 10,000 years. The only continuous civilization that's lived for longer than that is the Australian Indigenous peoples, who have survived the magnitude of change of 5 degrees from the last ice age to the current interglacial period. And throughout that period of the last 10,000 years, carbon dioxide has not been higher than we have at present, and the rate of change of carbon dioxide is faster than the rate of change in the last, well, the changes from the last ice age to the interglacial period. So we're rapidly changing carbon dioxide. It is leading to rapid temperature changes at a faster rate than natural ecosystems have ever experienced, faster than any humans have ever experienced. And we need to be wary about that. In terms of storms, droughts, floods, he focuses on the United States, and there are regions of the United States for which droughts have got much more severe. There are other regions for which flooding has got more severe. And so it depends on exactly what time period you're looking at, which geographical region. I have shared a room with John Christie at a conference 40 years ago or 30 years ago in the United States. It must have, yeah, look, I can't tell you exactly when it was. I understand where he's coming from. He is a highly religious person, and I'm glad that he has faith in his religious belief, because I don't believe his science anymore.
Okay, look, we've got one more question. I'll have to make this the last one. It's from James. He says, what arguments do you find to be the most effective against people who want to prevent climate action?
Look, what I try to do is ask them what they value in their lives. And what I then try to do is to use arguments about the climate change impacts on the things that they value, whether it's their family or their jobs or beaches or forests or animals or plants. And the only argument that they usually come up with is wishful hoping for a technological fix to suck out carbon dioxide from the atmosphere at a faster rate than burning fossil fuels can produce it. I then talk about the volume of solid carbon dioxide as dry ice and the height of the mountain. If that dry ice was just occupying either an Australian rules ground or a rugby ground, and how high that mountain would be, and it would be more than 8 kilometres high. It's pretty easy to work out because dry ice is roughly the same weight, mass as water ice. And unfortunately, you can work out that that's approximately 1 tonne per cubic metre. And you can work out how many billion tonnes that is and how many billion cubic metres that is. Unfortunately, we're doing 50 billion tonnes of CO2, and CO2 in terms of billion tonnes, that's a very tall mountain, even if it is 100 metres by 50 metres or 100 metres by 100 metres across. It's higher than Mount Everest and still going. It doesn't get to the moon. We've got to move that stuff or stop it getting in. And unfortunately, Mr. Dyson hasn't yet got a vacuum cleaner that sucks carbon dioxide out of the atmosphere.
Well, I think we're going to have to finish it there. That's been an absolutely fantastic presentation, David. We are so grateful for you giving us your time tonight. The majority of our members and supporters will be watching this on our YouTube channel. We thank you very much to all those who've turned up tonight to hear it live. And that ends tonight's formal proceedings. So thanks everybody for coming, and I wish everybody a good night.
Ken, can I just say something at the end before you close everything?
Absolutely.
I think it is important to realise that we do have solutions to solve this problem, both in Australia and everywhere else and around the world, that Australia has massive opportunities from our sun and our wind and our geography that we should be taking advantage. We don't have to dig up all the coal in the ground in much the same way as we didn't have to dig up all the stones to finish the Stone Age. We can leave the coal in the ground to finish the coal age and move into a new renewable energy age. All you've got to do is vote that way and persuade your superannuation scheme and your local politicians, your state politicians, and your federal politicians that you are concerned about this problem, and it will get worse unless they acted yesterday or 10 years ago. And it will still get worse, whatever they do.
Well, that's a positive message to end with, and that's absolutely. Thanks for coming, everybody, and I'm going to end the formal proceedings.